All right, hi, and welcome to Chapter 3. Now, Chapter 3 is going to be tricky. We are going to learn a lot of information on here. So, do not feel like you need to memorize this. If anything, you should take example notes and hold some programs aside to use as reference. So every time we build something, it might be worth opening up like a Google Docs or some sort of text editor or something where you can save copies of your code so you can return back to it. Again, this is going to be pretty complicated, not because the topics are difficult, but because there's just so much information. And remember, you don't need to memorize this. All you need to do is know where to look it up and how to adapt or kind of change it to meet your needs. All right, so let's get diving into something called turtle graphics. I'm not exactly sure where the turtle name got its origin from, but it's a very, very popular system within Python, and a lot of people use it to kind of understand the basics of visual design and graphics and things like that. So first off, what we need to do is we need to bring in something called a library. Libraries are a set of pre-created instructions that Python doesn't natively know how to work with, based on its initial build, but you can bring in these extra instructions to take care of a lot of really neat things. So the first line, every time we need to do graphics, is we need to say import turtle. And when you do that, it's kind of like with a smartphone where you first get it, you install apps to enhance the features of your device. Very much like in Python, when you say import turtle, you're not necessarily installing an app per se, but the idea is kind of close. We are bringing in extra features and extra capabilities to make our lives easier and also do more cool things on there. All right, so that's the first thing that we want to do. The next thing I want to do is I want to create a little nickname for our turtle's screen. So if I say screen equals turtle dot with capital S screen, what this does is it just allows us to send commands to our screen by giving it a quick little nickname. All right, turtle.screen is our drawing window. So this kind of sets up everything so we can send some basic commands to it. We're not going to look at it exactly just yet, but in a couple lines of code, we're going to see that unravel. Our third line, this actually makes a drawing object. So I'm going to make my drawing object. I'm going to give it a very short name because I'm going to be giving this little object a lot of commands. So I don't want to write in a crazy long name. So I'm just going to say t1 equals turtle, lowercase, dot with capital T, T-U-R-T-L-E. All right, t1 equals turtle dot turtle. All right, now we're going to click run and nothing is going to happen. And that's all right for now. We want to give some instructions to this turtle, but this is kind of like a test run. When I click run, it doesn't really do anything. It says, all right, I'm ready to go, just in case you need to do anything. First instruction I always love to do is we're going to tell our little turtle. Our turtle's name in this exercise is T1, so I'm going to say T1 dot. So it's kind of like me saying somebody by their name, hey, Jimmy, do this action. It's kind of like saying that. T1, I'm trying to get your attention. I need you to go forward, F-O-R-W-A-R-D, and in parentheses, I'm going to tell this little turtle to move 100 steps forward. We're just going to see it move. And when I click run, oh, there he is. This little turtle guy, this little arrow right here, moved 100 steps forward. It doesn't have to be nice even numbers. If I tell my turtle to move 39 steps forward, it's just going to move a little bit less from there. All right. So this is actually really helpful in drawing different types of graphics. We're just drawing with a pen, but eventually we're going to learn how to change the color of the pen. We're going to be able to make it so the turtle won't leave marks. We're going to make it so the turtle can turn the angle it's facing. We're going to change the width of the pen. We're going to do a lot of really cool graphical stuff. But for now, let's get those base instructions up and running. So my turtle moves forward 39 steps. Okay, cool. What if I don't want it to move forward, right? This is a very limited task, right? Can I tell it to move forward another 22 steps? Sure, I can. And there he goes. But what I'm interested in is changing the angle that the turtle is facing as it moves. So I'm going to say T1 dot left, and in parentheses, I'm going to put 45. I'm going to have it turn left 45 degrees. So I'm going to run it. Oh, look at that. That little arrow is now pointing in a slightly different direction. Well, let's tell it to go forward again. How about 37 steps? Oh, and there he goes. Look at that. He's actually able to move around and navigate. What if I said t1.left and in parentheses 73 degrees? Well, let's do something kind of interesting. And then let's tell our turtle to go forward another 123 steps. Now we run it. Boom, boom, boom. Oh, look at that. I'm almost kind of making like a diamond upside down shape. That's pretty neat. All right. What I can also do is my turtle can be told to move right as well. I'm going to have it move right 90 degrees, and then I'm going to have it go forward another 100 steps. Now look at that, kind of making like a weird clunky S shape. That's not anything amazing. We're just trying to learn the basics of these instructions, all right? So that's kind of the base of like how we can move our turtle and make it do things, all right? Now what if I asked, I'm gonna put a space for some different directions. I'm gonna have it turn right another 90 degrees, but then I don't want my turtle to move forward and leave a mark. What I want to do is I'm going to say t1.up with parentheses. And then I'm going to tell my turtle to move forward, let's say 43 steps. Let's see what we get. Oh, look at that. This turtle didn't leave any marks of where it's moving because I told the turtle to lift up the pen. I'm saying basically don't leave any marks. You know, imagine this poor little turtle has a Sharpie marker taped to its shell, and everywhere it walks it kind of leaves a trail. First off, very mean, but it's okay. It's a digital turtle. The turtle actually likes drawing and walking around. But when I say t1.up, that little turtle lifts up his little turtle butt and doesn't leave any marks anywhere that he moves. I can tell the turtle to turn right another 90 degrees and go forward 150 steps, just to kind of make sure that it's still moving without any sort of pen marks. Oh, look at that. Now, if up picks up the pen, I think we can all kind of realize that t1.down. And remember those parentheses. The parentheses are very important, all right? You'll notice every turtle command has some form of parentheses being used. And let's have the turtle move forward 39 steps from there. Okay. Boom, oh look at that, he started leaving marks again. So it's kind of like an on-off switch, kind of like light switches. You can turn the lights on, you can turn the lights off. You can turn the marker on, you can turn the marker off. All right, so that's kind of the first basic steps of making a turtle move. In this type of scenario, it would be best for some exercises to try to draw a square, a rectangle, and a triangle. All right, so we are in the second section of the graphics and the introductory stuff, lesson 3-1. So if I end up telling my turtle to go forward 5,000 steps, let's see what happens. There he goes, and he's gone. But here's the thing, if I try to extend my screen, wait a minute, where did his pathway go? All right. When you run Python, especially on what I'm using in this coding box, the graphics window is kind of auto-calculated, or it sometimes fits to a default size. So when you are designing and building this, you kind of want to have an idea of how large your window space is, right? You don't want to create all these really, really nice graphics, and then your graphics get cut off the screen or something else like that. Also, it's very important to be precise and be in control of what we are building. So I'm going to show you two different tricks today, just to kind of show not only how large to make your screen, but also how to change the background color. And we're going to flip the order of those because right now this is a gray background on a gray screen. So like it doesn't really show like where the borders are in our code. So the first thing I'm going to do is I'm going to show you how to change the background of the screen. So I'm going to say screen.bg color, and in parentheses and quotes, we're going to choose a color. I'm going to do orange. And if I run this, oh, whoa, check that out. My whole screen is now orange. It looks like I have a very specific size on here. And if I run it, look at that. Depending on what size my screen is initially, that will kind of build out my screen. So if I shrink this all the way down to here, oh, look at that. It gave me a little tiny screen to build. So we kind of have like these magical barriers placed in. As someone who likes to be in control of their code and make sure that things are not necessarily behaving unpredictably, I always want to make sure that I'm in control of how large my screen is. And also, it almost looks like this is drawing perfect squares. What if I want a rectangle, kind of like a modern day television or like a smartphone screen or something else like that? So before I change my BG color, this has to happen before, right? I'm going to say screen.setup, and in parentheses, I'm going to put in two numbers. The first number will talk about the width, how wide it is, and the second number will talk about how tall it is. So let's start with a pretty easy number, but we also want to be able to distinguish or see what's each number do. So I'm going to say 200, 100. It should be a rectangle, twice as wide as it is tall. Let's give this guy a spin and see what we get. Oh, look at that. Wow, that's a pretty small screen. So it looks like these numbers are actually, they need to be pretty darn large numbers in order to make good stuff. So I'm going to say, how about 600 by 400? Oh, there we go. That's a pretty decent screen size. And now, even if I shrink this over and run it, it doesn't matter. My screen size is still going to stay consistent. What this first number talks about is the width, but what it means is it's in pixels, right? The little tiny dots. If you zoom into a photo or anything, it eventually turns into little tiny dots of each color, right? And this also talks about the height or the up and down distance in pixels. So why don't we test that, right? I'm going to say T1 dot forward, in parentheses, if it's 600 entirely wide, then half of it has to be 300. So let's test this. Let's make it go forward 300. Look at that, stopped right on the end of that line. Well, that's kind of neat. We know exactly how much space we can go. What happens if we go a little bit further, maybe 350? We lost the turtle, it hopped off. It's still kind of theoretically drawing back here, but what we care about is the line that it leaves on our code or on our drawing canvas, all right? So this kind of gives us an idea of the barrier or how far we can go. Now, again, if we run into angles, that's going to get a little weird, right? Go forward 30 and then T1 dot left, let's say 72 degrees, and then I say T1 dot forward the 200 for this 400 height. Oh, it didn't get all the way up to the top, but it does give us kind of like an idea of how far we can go. All right, so just keep that in mind as we start building things. Lots of interesting things. Whatever color you want to put in here, you can, right? I can run this red. I can run it blue. I can run it green. If I wanted to, I could run it black, but nothing's happening because it's black ink on a black screen, so you don't get to see that. All right, so have fun with different colors and things like that. See how it looks, see how it plays out, and see if you can draw some neat things, right? Some of the goals of this lesson, you want to make a square, which I'm going to give you a huge hint, has 90-degree angles. You want to draw a rectangle. A rectangle is just a square with slightly longer sides, and a triangle. That's going to be a little tricky because it might change the way you think about math instructions versus properties of a triangle. It's up for you to figure it out. Remember, trial and error, and remember, you can always just keep adjusting numbers and keep adjusting instructions until you get the results that you want. All right, so that's our introduction to graphics. We learned how to move our turtle, make it do things, kind of walk around, how to turn its angle, pick up the pen, put down the pen, change the background color, and most importantly, change the size of our screen. You want to be in control of your code from start to finish so that you don't get confused in case something goes wrong.